to be transferred to the application for the application to provide a response. SOAP stands for Simple Object Access Protocol. We'll get into more detail about REST and SOAP later on in the course. What's an example of a stateful transaction? An example of this is something called File Transfer Protocol. Forget about HTTP. This is where you have two computers and you're transferring files between each other. You know who you're talking to and you know what needs to be done. That is, you're talking to this computer and you want the file to be transferred before the request is made. That makes it stateful. Let's look at another example of stateless. Let's go back to the late 80s and early 90s. They had these phones. Somebody would call, and when they called, the phone would ring, and you had no idea who it was and what they wanted. You pick up the phone, you'd say hello. That's an example of a stateless transaction. You'd hang up, the next call would come in, you have no idea who's calling and what they wanted. Stateless. What's an example of stateful? This is where you know who is calling and what they want. For example, your friend says, I'm going to call in 30 minutes and let's talk about what we're going to do tonight. Then when you pick up the phone, you already know who's calling and you're going to talk about what you're going to do tonight. So you have this memory of what's going to happen when the call comes in before it comes in. That's a stateful call. HTTP is stateless. In other words, it doesn't remember what happens between one HTTP call and the next. So then how is it possible that Amazon seems to remember over time you putting items into a cart? The answer to that is cookies. Originally the term cookie was fortune cookie. Later on became magic cookie, and now we know it as cookie. What makes a fortune cookie unique is a piece of information is in that cookie. What does this have to do with the HTTP world? Well, if an application and a client, such as a browser, can exchange information, they can continue a session. Specifically, if this session ID is in the cookie and it's traded between the application and the client, the session can continue. The idea of cookies was made by Lou Montulli back in 1994 when he was working for Netscape. Netscape was a browser at the time. Let's look at an example in reality. Here I'm ordering a table and some chairs. I have two items in a cart. I press F12 and I see a cookie for Amazon. And in that cookie is a session ID. The browser will send a cookie to Amazon that contains this session ID, and Amazon says, hey, I've got this session ID, looks into the database, finds the session and everything associated with that session, including the two items in the cart, and sends back the web page specific to the session that you're in. How are cookies set? Often cookies are set through header lines. That is, in HTTP we have 4 sections: the start line, headers, blank line, and body. In the header section, you're able to create multiple lines. When the application sends back a HTTP request response, it can start a header line with set cookie. That tells the browser to create a cookie. Then the browser sends back HTTP response with a header line that includes cookie to start. It doesn't have to be done this way. For example, you can create cookies using PHP and JavaScript. Let's go back to Lou Montulli. What did he do? He created something. He created this idea of a cookie that is used throughout the web today. Creation is a big part of being in technology. Don't think that everything I tell you, it has to be done this way. Feel free to be creative and feel free to have fun and question the way things are done. Let's talk briefly about HTTP security. Cookies are not executables. Cookies are lines of text or data. Cookies don't store passwords. Cookies can use tokens instead of passwords. For example, in Amazon, you see that there's not only a session ID, but a session token. This session token changes every time you refresh Amazon or go to a new page in Amazon. So not only there's a continual session ID, but there's an encrypted token to go along with it. Applications store data along with the session ID. For example, an application can associate an IP address to a session ID. So if somebody steals that session ID and tries to use it from another computer, well, that other computer doesn't contain the IP address that you were using, and the application can mark that as a fraudulent request. Punishment. Obviously, from hacking, you can go to jail, you can be fined. Not only that, but you get a police record. Imagine trying to get a job in IT when they find out that you've been a hacker. Multi-factor authentication means identifying yourself more than once. Let's say you're logging into your bank account. You log in using your username and password, but not only that, you have to identify yourself again, possibly using a code that was sent to an email or your cell phone associated with that bank account. Changes are always occurring in security. One of the latest ways of providing identification, that is authentication, is fingerprints. Antivirus software. I put this here because you don't want to depend on antivirus software as a first line of defense. Antivirus software can find out that somebody got hacked and put it into their system. Well, you don't want to be that person who got hacked and had that information, that risk, put into the antivirus software. Human error is often a cause of security incidents. You're clicking on something or pressing on your cell phone something that you shouldn't. Be proactive. Don't just assume everything's good. I'll give you an example. I was hacked myself. My credit card found that somebody was charging me a small amount, let's say $8.50. I forget what it was, but it wasn't much. Month after month after month on a regular time frame. It looked like a legitimate site, but I knew myself that wasn't a legitimate site. If I didn't check, they could have been in there for years, 10 years, 20 years. They could have taken thousands out of my account for doing absolutely nothing. Always report. If you get spam in your email, don't just delete it and put it in your trash. Report it. That way, not only does it help you, but it helps everybody else. How does HTTP work? How does the web work? HTTP, request and response. There must be some kind of infrastructure behind the scenes, hardware and software, not just the HTTP request and response, that enables the internet. Let's talk about that. Let's compare back when HTTP was not used to today when it is used. Let's use the telephone example that I talked about earlier. Remember, we talked about phone calls where somebody would call on a telephone like this and somebody would pick up on a similar telephone. Ding, ding, ding. Somebody would pick up. Hello, who is it? What would you like? Let's compare that to Amazon. Here, for example, I'm ordering a table and some chairs theoretically from Amazon without using phone calls. Calling Amazon and say, hey, can I order these 2 items? I'm able to do this using HTTP. What was the application back then? Well, back then they didn't call them applications, but essentially it was the company that ran the telephone service. In my case, it was Bell Atlantic. They ran the telephone service in the East Coast of the United States. The application, if you're using Amazon, is Amazon. If you're using Wikipedia, it's Wikipedia. If you're using Google, it's Google. Back then, who was the client or the requester? The client was the person calling. Now, who is the client? The client can be, for example, a browser. You can make a request to Amazon through the browser, or it can be done through programs. Let's say, for example, you have a business and you're running short on certain items. You can make that HTTP request for additional items through the program to another company that provides those items. You don't have to use a browser. You could do it through the code. Who is the initial receiver? That is the first receiver of the request. That is the telephone. The telephone rings when the request is made. Now it's a load balancer. The request is made, it sends to a load balancer, and the load balancer then finds out which server is available. Certain servers may be busy. It checks and it says, hey, you server, take this HTTP request and provide a response. So who was the server back then in the telephone example? It was the person answering. Now it's called an application server. It's the server in the application. Client-server connection. How do you connect the client that is a requester to the server that is meeting that request? Well, back then, between the telephones were copper wires on telephone poles. These days, they can be cables or satellite. When you're using a cell phone, that cell phone sends a message to a cell tower, which then converts it into a wire, which goes to the application. If you're using a desktop, like I'm using a desktop right now, it starts out on cables, but it can be also done using satellite. This isn't common, but it can be done. For example, Elon Musk created internet server through satellite. When there was a war between Ukraine and Russia, it was possible that these cell towers would be destroyed, wires would be destroyed, but if you put a dish that could connect to a Starlink satellite and connect your cell phone to that dish, then you can get the internet. Memory. Where's memory stored? Well, back then, the memory was stored in the brain of the person answering the call. These days, the memory is stored in the application database. Now that you have an introductory sense of how HTTP works behind the scenes, what are the benefits of HTTP being stateless? Well, scalability, that is growth. If you look back at the original example of the server, back then with the telephone, the person answering was the server, the person who met the request. It could be anybody. The telephone rings, you could have 10 people, 100 people, 1,000 people answer the call and say, hello, what is it, would you like? There's no memory needed. The same thing with HTTP. The application server doesn't have to have any memory of the request coming in, so you can keep adding more and more application servers to meet demand. Next, resilience, crashability. The reality is that, for example, with Amazon, they have load balancers all over the world. They have application servers all over the world. If one particular load balancer goes down or application server goes down, not a problem. They could just use backup load balancers and application servers because they have them all across the world. Less memory is needed. These application servers don't have to keep any memory of the HTTP request coming in. Let's take a look at an actual server. Believe it or not, servers are on your Windows computer if you have a Windows computer. If I type here services, I'm able to open up services. In other words, servers. These are services from servers. You could think of these as servers. Let's look at the first two. You could see two servers. One is running and one is not. This one is not, so it won't be providing any service. This one is running, and this is the Adobe Acrobat update service. If we double click on this, and this service is running, as you could see, and provides updates to Adobe Acrobat. There's a variety of ways to set this up. You don't have to have a load balancer. You can have the request go directly to the application server. If you're a gigantic company like Amazon, you're obviously going to want to use load balancers and servers. Now, the load balancer is a piece of software that can be on an individual Linux machine. Usually there's Linux or Unix-based computers rather than Windows computers because they're better able to handle requests with speed. So you can have a load balancer on one Linux computer and then application servers on another Linux computer, and then application servers on another Linux computer and another load balancer, and so on, and have the load balancer provide some kind of algorithm to choose which application server is going to meet that HTTP request. When that application server needs any kind of information, then that application server contacts the database. And this overall is how the HTTP infrastructure works, the hardware and the software.